Hi, this video is an update about the Maya to jbeam script that sends your model and with some care the dynamic parts of it to BeamNG drive, right? So here in Maya, the first thing you have to do is make sure you are using under settings of the Maya preferences the word coordinate system Z up. By default it's set to Y up, but we want Z to be the same as torque engine, right? I like to use my working units as centimeters because I don't like to use comma very much when typing stuff, right? So Z up, save, and we're good to go. Now we have the right resolution geometry, and we also made a lower resolution, a simpler mesh to use for the dynamic solution, right? For the base of the dynamic solution. The mesh itself does not care much information. We are just interested on the vertices of it by the moment. Later we will use it for triangulation too. So we have the Bola is the high resolution mesh, and Bola Soft is the proxy I will use to create nodes for the dynamic solution. The first thing you have to do is, I don't know if this requirement is really true, but let's make it, some of it is, right? So the first thing you want to do is place it on the ground, right? Right now it's centered in the middle, and we want to place it over here, about here, right? A little bit above, no problem, right? But we also want the pivot of our objects to be on the zero of the word coordinate system, right? Right now it's centered on the ball and translated 100 units above. This ball it's about 2 meters wide, 2 meters in diameter. It's very big, but it's the approximation scale of most of your objects we will be dealing with, right? So keep in mind it's about 2 meters in diameter. So the first thing, let's grab it both for ball and our proxy geometry and set the pivot to the zero coordinate system. You can hold the D key on the keyboard and X key to snap it to the vertex. D key lets you move the pivot. Let's say if one of the pivot and are in a different position, take care of it too. But you can also use, if you drag the middle mouse button, you will move it, but you can press X and it will toggle the snap to grid, and with the middle mouse button I drag and it snaps to the grid, right? So snap to the middle of the grid, and there it is. Notice it's saying it's still translated in the ZX, so you go to modify and freeze transformation, make sure everything is checked. Freeze transform, now it's on the zero, and that's what we want, right? So the first thing, let me grab my notes. The first thing we want to create some the nodes, right? Let's hide the high resolution with Ctrl H, and under the dynamics menu in the soft rigid bodies, create soft body, right? Make soft, nothing fancy. Okay, this created some particles on each vertex of my proxy geometry, right? I would just go to the attribute editor under the particle shapes in the render attributes, toggle numeric just for the display sakes, okay? Display sake. Now we have the nodes as we've seen before, and we will add some springs. Create springs from the soft rigid bodies menu, having selected the soft particle inside the geometry, right? Create springs, and let's use wireframe. It will fail, but I want to illustrate how important it is to use a different system than just mesh. Let's create, and now we have beams between the nodes, roughly very uniform, some hexagons and pentagons, and that's it. So I have beams, the nodes, and the high resolution geometry which is hidden. With Shift H we can get it back. Right, so let's open the script. With Bola Selector we get the visual mesh. This we will export to a collada file. The particles are our nodes and beams are our springs. And let's grab a template and let's write the jbeam. To the vehicles folders of BeamNG drive, I'll create a folder named ball. Right? Inside it, we'll create the ball jbeam. The name is the same as the folder. Save. And now we also export our high resolution mesh to a die object, right? Collada unit. Make sure units is set to automatic and axis conversion is set to Z, right? Z up. Let's name it right inside our newly created ball folder. Let's name it ball as the folder and as the jbeam file. Right. So now under vehicles we have the ball folder, which has ball and ball.die and ball.jbeam. I will just copy this diffuse texture of the object, and now we go to BeamNG. Right. Let me check if everything is okay, and everything is okay. So let's press Ctrl E, and here is our ball. Let's load it, and there you have it. You see, it immediately collapsed in a single plane because it has absolutely no structure. There are no three beams connecting. There is very little structure, and this has very little to do with the values we have here. We need some more structure to keep it together. It wouldn't make a difference if we were to create it from a metal template, for instance, right? So let's get back to our particles and beams. I will isolate it. And the fact is, what is happening is everything is very easy to bend, and that's what's happening. It's flickering because it's in the same plane as the ground plane, not something particular that we should worry, right? So let's create more structure to it. One way to create more structure, I will just delete the beams. And let's say we want to create it in a different fashion. I'll hide the high resolution again. And let's say in the create springs, we want to create more structure, and we use the creation method all. It creates a lot of structure. Between each one of the particle of the nodes, it creates a connection with each other. And so you can see it creates a lot of beams. This will be extremely heavy to computate. If we go here and I will check here, it said it created 1,770 beams. This is less than the vehicle has, but it's a lot still. You don't want this structure, and also you have a lot of redundant. You don't need so much. Optimization is it's a matter we'll approach later, but so all is a little bit overkill. Delete it, and I'll create some more structure, but not so much. Let's say, let's get an hexagon here, and let's take this one for instance, right? Made by the 3, 9, 17, 26, 16, and 8 nodes. So we want to create a beam between 3 and 9, but we want some more structure, and we will create from 3 to 17, 3 to 16, and 3 to 8, and so far so on, right? But we want to limit a range of it. So what we have to do is create a measure tool, grab a distance tool, snap it to the vertex 3, and let's say the vertex 26. And this is the maximum distance we want. We don't really want between 3 and 26. We want only to 17, and so we will use a number lower than this, right? Let's use a 70, just to make sure the other locator, and let's snap to 70, 65. So if in the maximum distance, we set something between 65.5 and 75, right? 75. We will create a beam from here to there, but not from 3 to 17. No. Let's just delete the measure 2 to 26. So let's place a number between them. For the maximum distance, let's remember to select the particles. Using the minimum maximum create method, we could establish a minimum, and let's apply. So you can see that now it created as we planned, right? It has more structure than just the wireframe, but not so much to become a problem to the computation of the real-time dynamics, right? So everything is in place. The beams, it's already here because it's the name of the object, as I was deleting. And let's set it to rubber and export. Now we can press Ctrl R to reload our geometry with the new settings. Now it's a little bit more, it has a little bit more structure. You see it's crumbled a little, but it maintains some of its shape, right? Now we can get back here, and if you want it to be more resistance to deformation, you increase the deform value. Let's place it to 1000. Write the jbeam, and press Ctrl R again. Right, now it's more fluffy. If you want it to bounce a little more, we'll add more springiness. Right, springiness, I don't know if that's a word, but let's do it. Now it's more resilient overall to deform. It tries harder to get back to shape. If you want to make it more soft, the movement, so it doesn't jiggle too much, we increase the damping, right? And so I just want to show a different method to create nodes and modify springs that will be useful in some other circumstances. For instance, if you select your object and make it live, now you can place objects over it. So we get to particles and particle 2, and we can create some particles just by clicking where we want. So I created 8 particles. That's again the particle shapes. So go with to numeric so we can see it better, right? So we have some particles over the geometry. Of course, if I were to deform this ball, we would need a lot more. So that's where it comes in handy to use a mesh as a base to create particles. You notice that as I create these particles, I didn't need really another mesh. They exist on space. Remember, we just need the node's position, not something related to the mesh, right? So let's hide the bola, and we have particles here. And again, if we were to create springs, the only thing we won't be able to is to use a wireframe to create them, because we don't have a wireframe to guide it. So you have to use the all method or the min and maximum, right? Again, if you create the all method, it creates a lot of beams, right? Another way you can do is create springs and edit them. Not only you can delete them, you can also create some basic springs using the default methods, but you can also create them part by part. If you go to component selection and use particles, right, you can grab, for instance, this far and use the all method, for instance, right? So you have the particle 1 and beams, but you want to continue. So you grab your particle, component particle, grab this, and also your beams, and select add to existing spring, right? And again, if I want between them, I'll add with the all method, but just for this far particles. Make sure you don't duplicate existing springs, so it doesn't create another spring between 4 and 5, right? And that's pretty much it.